So basically, to be a central angle, it has to obviously be in a circle, and the vertex of that angle actually has to be in there. And I gave you different colors here so you can see that just kind of that green is really the angle we're talking about, right? And so that is a central angle because if you look at P, angle P right there that you can see is in the center of the circle. Kind of forget about that arc that it's creating right now. We're just looking at the angle for right now. We're going to talk about the arc very shortly. So a central angle is quite simply an angle with the center of the circle as its vertex. I think most of you probably knew that already. Or you were probably going to give me a very similar definition. Because remember the other day, or yesterday even, just getting the definition of circle, we did a pretty good job, but it's still not as easy as one would think it should be. So can somebody maybe name what is a central angle in the circle over here? Now you got to be a little careful. Yeah, RPQ would be fine. I don't know if I have it there. Nope. So angle RPQ is just fine. The reason I would caution you on that is just because really the central angle could be that one, or the central angle could be that one. And if you just say angle P, do I know which of those two you're referring to? Unfortunately, I don't. And so I would stick with probably trying all three. Hopefully, when you get to your assignment, they'll be nice to you and do something like this, like maybe put a 1 in there or something like that. So you can say angle 1, and then it'll be a little easier for you. But watch out, because in central angles, often we want to think of the smaller one as the one they're talking about, but maybe it's not. In this case, so be careful. Well, a circle has a total of 360 degrees. I think we know that, but I wrote so big the degree symbol looks a little low, but you get the idea. So that's basically talking about the angles and what we could be talking about. Now we're going to stop kind of looking at the green and start looking at the blue. Do you see how this green kind of comes here and kind of, what if I made a cut right there and a cut right there? There's a blue piece right in here that kind of creates an arc. Okay, and or you could look at it the other way. Once I cut there on R and cut there at Q, it makes a big arc going that way. All right, so there are a lot of arcs you could take a look at. And so a minor arc is any arc that you have that has a central angle less than, well, what do you suppose that is? You think it's 90? Is it 180? What do you think? Minor arc is less than 180. So if it says it has to be less than 180, does 180 count? No, it doesn't. It has to be less than. So how about 179.9? That counts. How about 21 degrees? Does that count as a minor arc? Yep. So do we have a minor arc? As you look up there, do we have a minor arc? Yeah, we do. And do you think it matters which way you name the arc? Like, do you have to go clockwise, counterclockwise, or anything like that? No, it doesn't matter. And so what you might do is RQ, but then what do? Do you put a segment, or what? It's not really straight, is it? Is it something I could straighten out if I cut it? It is, but so what do you put for that, for a symbol? Yeah, you just put an arc. Yeah, pretty simple. Right? Don't make that a straight segment or a line or anything. Just make a little arc over it. So QR would have been fine for that one. Well, if a minor arc is less than 180, a major arc is probably greater than 180. Do we happen to have one of those drawn in the picture? And here's where I would be careful to the best of your ability. Could I technically still say arc RQ if you went the other way? But what I would do is make sure that the people are looking at the arc you're talking about, which is why I put another point in there to kind of help people get around. It's so what I would do is say, and it doesn't matter where you start, but say R, S, Q. Does that make it obvious which way I want people to go? Go from R and then to S and then to Q? I think that makes it very obvious, but is that an acceptable answer the way I have it written right now? Not quite. I need the arc, exactly. And it's okay. You could have 4 or 5 letters underneath there if you want, but you'll make sure you have enough so that people look at the right one. And I would definitely agree that RSQ is a major arc in this one. So this one here says less than 180. That one says greater than 180. Well, what if the central angle is exactly 180? Is that a minor arc? Is that a major arc? Not according to our definitions. Well, what is it? Okay, not a median arc. Good idea, though. You should know what that's called. What if it is exactly 180 degrees? It's a semicircle. Isn't it? Half? Wouldn't you have half the circle if your central angle was 180 degrees? And if you want to draw yourself a picture, that's fine too. Look at right there. It is a diameter. I heard somebody say that. That was a good description. But don't you look, like right here, isn't that? And it is a semicircle, not a hemicircle. Okay, semicircle, hemisphere. Keep it straight. Okay. Okay. Any questions? All right. Arc length. Basically, how I look at arc length is maybe if we were looking at this example down here. Once again, don't you agree I could cut it at R and cut it at Q, and I could take that little arc there, and I could straighten that out, couldn't I? And then if you measure that, that's how long the arc is, right? Well, that's what arc length is. And so very simply, there's a formula for that. So this is saying this M means measure of the angle divided by 360. What that basically tells you is what fraction of the circle you have, right? And then you take it times 2 pi r. Have we seen 2 pi r before? What is that the formula for? 2 pi r is circumference, right? Do you agree circumference is going all the way around the circle? So that's how long, if I just basically look at it this way, for circumference, if I cut right there and I just straightened out the entire circle, that's what circumference is, right? And now we're saying, well, what fraction of the circle do I have by taking the measure of the angle divided by 360? But you have to be careful. The actual problem has to say arc length for you to be looking for arc length. That's where I'm talking about. You have to look at directions. And does this one say right here? It says determine the length of arc QR. So does it want arc length? Yes, it does. If it does not say arc length or length in the problem, do not do this. All right? So for example, let's take a look. Well, if we're looking at arc QR, we know they must be talking about that one because what letter is not in there? S, exactly. So we're not talking about that one. So you look at the central angle that creates it. And it's 90. Agreed that the 90-degree angle is the one that creates it? So we're talking about 90 degrees is how many we have. How many total? 360. So I hope you can agree that's the fraction of the circle we're talking about. So basically, if you were to reduce that, if you want to, 1/4. Right? 1/4 of the circle. But you don't have to do that if you don't want to. And we're going to take 2 times pi. Well, what is the radius for this particular one? Pi. Okay? And once again, you kind of have to watch whether they talk about exact answer or what they talk about. So let's say they did ask for exact answer. You'd have to do this. Well, 90 over 360 becomes, well, that's 1/4. Okay, so we got 1/4 times, everybody see where the 1/4 came from if you simplify this fraction? Okay, and this is 10 pi, right, on the inside, right here. So that's basically 10 pi over 1, right, if you had to write it as a fraction. Everybody okay with that? So it'd be really 10 pi over 4. Do you think I would accept that as an answer, 10 pi over 4? Not quite. Is it because it's 10 over 4, or what's the reason? Is it because it's improper? No, it's because it's not simplified. And so this should be 5 pi over 2. Do we have a label for this thing? Nope, not really. So 5 pi over 2 would be the way to get the exact answer. Is there any questions of how I got to that? No? Now, there's no guarantee that's what the directions are going to say. It could say just to round it, and well, then you just multiply it out. And if they're asking to round it, let's face it, you could just come back here and just kind of type that in. All right? And so you're probably hoping for that option, right? Because it's a little less work to just type it in. But what do you think? In this case, do you think it's going to be more than 5 if you look at the picture, or do you think it's going to be less? Again, I'm cutting it off, straightening it out. And this much is 5, but do you think it's going to be more than 5? I think so too. Quite a bit probably, right? So you take 5 pi and divide it by 2, and you get what? 7.85. So if you round it, it's approximately 7.85. I think it makes sense that it's more than 5, right, if you look at the picture. So are there any questions about the arc length problem that we just did? Yeah. Right. If they ask you to just round, you can go right back here and type it in. Yep. But if they ask you for exact, then you kind of got to go through the simplifying steps. Okay. We're good enough for what we got to do next. Does this question, it's talking about the same arc. Do you agree with that? Does this question down here, it says determine the measure of arc QR. Do you see the word length at all in that question? So is that asking for arc length? No. That's what I'm talking about for directions. This one up here says arc length. This one does not. You're going to prefer to see these bottom ones because when they ask these, no arc length involved in that question at all. All they want is the central angle that creates it. So the answer to this one is 90 degrees. Much easier, isn't it? Well, let's face it, we'd rather have those questions. But some people sit there and they find arc length for these questions, and that's not what they're asking. Do you understand the difference in the questioning? Okay. Well, with that in mind, why don't you go ahead and try answering these. Now take a look. Do you see length in any of these questions? Does it say arc length anywhere? No, so go ahead and answer those while I save this.